while you guys are returning to your seats, I just want to say, everyone, all week, right? They've been asking me, Eve, how'd you organize this conference? How did you and your team organize this space conference? I just tell them, you plan it. Thank you. Without further ado, I'd like to introduce the Beyond Leo panel. Moderating, we have Ryan Duffy, who is the executive editor at Payload. We have Blair DeWitt, who is founder and CEO of Lunar Station. Dr. Kevin Duda, who is a senior space systems manager at Draper Laboratory. Will Hovik, who is an engineering lead at Honeybee Robotics. And Dr. Forrest Meyen, who is the co-founder and CSO of Lunar Outpost. And also after this panel, we will be having a quick 5-minute introduction to another special guest we have here. So please stay seated after the panel. Thank you.
Awesome, Eve. Thank you for the introduction, and thanks everyone for being here. First off, I just want to say that it is wonderful to be back in my place of birth in Boston, and it's also even better to be invited to speak here on a campus of a school that I could never get into. So with that out of the way, I hope mom and dad, if you're listening to this asynchronously in a couple weeks, I hope you're proud. So thank you, Will, Kevin, Forrest, and Blair for joining me today. And I want to dive in with just a description of what your company or your organization does. Just for, I'm sure the lion's share of the audience is familiar with each of your organizations, but for anyone who's not, let's just cover the bases and get situated. And we'll go down the line for this, and then we can start bouncing around.
All right. So Blair DeWitt, and our company is Lunar Station, and since 2016, we've been working on advanced geospatial analytics for the moon. So we provide lunar intelligence. Our clients are commercial and government. And what we help our clients understand is what they're going to experience on the moon at any given place and time so that they have successful outcomes. And as a side note, it's just great to be back in this community. We've participated in every conference that has happened here. And it's just great to see familiar faces, new faces, young faces, and also old faces who are really part of the heritage of this, like Joanna Ensman, with her alumni jacket on, class of 67. So, although it's a new space age, there's a lot of heritage here as well.
Yeah, Kevin Duda with Draper Lab. We're just a couple blocks around the corner here in Cambridge. Our headquarters is here. Draper's been around 50 years this summer as an independent, not-for-profit R&D lab. So going back to our heritage, we were the first prime contract issued by NASA for the Apollo program, doing the guidance, navigation, and control and the flight computers for the lunar module and the command module. And we've been involved in every single NASA-led mission since then, and have a strong role in the Artemis program of today, as well as commercial space as well. So excited to talk about that today.
Everyone, my name is Will with Honeybee. Honeybee's been around for, some people know it, some people don't. Honeybee's been around for about 40 years, with only in the past like 10 or so really ramping up. But we've carved out quite a niche of space geotechnical tools. And we've been on every single Mars rover for the past couple decades. We work a lot with space mechanisms and sort of anything that touches dirt in space. So we're interested in situ resource utilization and developing mechanisms for advancing our species in interplanetary research.
Awesome. My name is Forrest Meyen. I'm a co-founder and CSO of Lunar Outpost. Lunar Outpost is a commercial planetary mobility company. We help scientists and entrepreneurs and space resource extractors to get access to the lunar surface and other places in space. We have a mission that's going to the moon this fall, so we'll be sending a rover to prospect for water resources and test some commercial payloads for Nokia and MIT and other programs. And we have a follow-on science mission in 2024 and another one that will be announced very, very shortly. So that's what we do. We help people explore the moon.
By very shortly, can't announce it on stage right now.
I wait about 50 hours.
Okay.
You want to give us, you heard it here
I'm-
first?
Yeah.
You want to do that sort of thing?
I'm going to be waiting with bated breath. So I think that the science and technology and engineering, which we will no doubt get into in this conversation, is all very interesting. But at the end of the day, it is a reality that money and capital makes the world go around and makes lunar exploration. I'm not going to even try to carry the metaphor over there, but I think that the prevalence of commercial space and the ubiquity of commercial space on this panel and throughout the various panels today is notable. And so with that in mind, I want to talk sort of about fundraising and just capital formation to make these projects a reality, and talk about who you partner with, how you find investors. But I want to situate this with kind of a historical backdrop. So Kevin, let's given the pedigree of Draper, what have you seen and your colleagues seen in terms of what has changed between the Apollo era and the Artemis era, and sending payloads to the moon, and with the next generation of payloads?
Sure. The good question, Ryan. So probably one of the big things that happened within the last 15, 20 years was the pivot to commercial services. Been a big change in terms of the acquisition strategy for NASA and the government, and certainly is something that we've had to adapt to, right? Because we were typically being part of embedded within a NASA team, being either on the government side or on the contractor side, and working to enable a government mission. Now with commercial cargo, commercial crew, and looking forward to some of these commercial missions like CLIPS, and iSpace, which we're a partner on. It's a completely different mindset, and a different mindset in terms of the risk that is being willing to be undertaken for those missions. How much software certification, hardware certification, all the certifications that are required for a Class D mission as opposed to a human class mission.
Mm-hmm. Mm-hmm. Yeah, I think we'll put a pin in that, because we definitely we'll get to that. But anyone else thoughts in terms of just funding models and?
Well, I think the venture capitalists that participate in this industry have a better understanding of risk. In any other industry, you can model out the expected outcomes very quickly. There is no model here. And so inherently, the capital you'll be going after are people that understand there's no comparables to draw on. You're kind of building it as you go. So it takes a special type of investor where you can't go up and down Wall Street collecting capital. You've got to find people that match your risk profile and align with the event horizon.
I think to add on to what you're saying, Blair, is as we're building out this capability, the CLIPS program is a perfect example. As we start to demonstrate this technology, it's exactly what these things are, right? Technology demonstrations. And as soon as we start to do that, we're empowering commercial payloads and the commercial sector to join in and really build out the path, buy down risk, and set a precedent. So I think along with the successes and just the story that's going to tell for investors in the future, it's going to help understand where the risks are, where the rewards are going to come from. You'll be able to wrap your head around it a little bit more. So I think the momentum of these NASA-funded CLIPS missions and the like will really enable this kind of commercial ecosystem to just flourish. But this is just the seed.
Forrest, any parting thoughts on that point?
Yeah, I think what's exciting about these opportunities with CLIPS is that startups will find out where these opportunities are, because there's so much excitement and interest from the startup community that the different types of business models that can get iterated very quickly. And the feedback loop that is happening now on the surface of the moon for what works and what doesn't is rapidly accelerating. We have 2 different business models for our 2 different missions. And from that, we've learned how we're going to change our business model for the next mission. And so that itself is information that, you know, VCs that partner with these sorts of companies are getting that extra insight that isn't even publicly available because it's happening so quickly.
Yeah. So a lot of you have referred to CLIPS, so why don't we just double click on that now? With CLIPS and with that program, and you know, we were speaking last night and using the ships, like the ships are starting to leave, that metaphor. How important will it be that those first ships are successful, or will that not make or break the program? You know, obviously there's the whole diversified aspect of this and the multiple shots on goal approach. So what are each of your thoughts there? And anyone feel free to jump in, especially since a lot of you know are directly involved with these ships.
Well, at least one ship hasn't left port. Right? So I think we're going to find out real soon, right? This year, you know, we're going to start seeing those vehicles launching and on their way to the moon. We'll find out real soon.
Well, iSpace is 3 weeks away from the moon at this point. They launched in December. And when I sent out the update to our investors at the end of the year, I told them how much I enjoyed December because Orion was splashing down while iSpace was launching to the moon. And when you think about the supply routes that need to be established coming and going, it was just a great day because it's that vision realized that as something's coming back, something's going. We need a lot of successes going to the moon in all shapes and forms. Any failure will be a disappointment. But I think the difference is because this is a commercial focused, you're spreading your risk across. It's no longer Apollo, well, at this point it'd be like Apollo 20. That's singular, and that's a problem. With private enterprise and multiples going, you're actually creating an exponential learning curve, opposed to a linear, which was Apollo 1, Apollo 2, right? That's a very slow way to learn how to do things. When you have 20 entities going to the moon, all with different systems, different methodologies, different engines, different technologies, you're going to learn a lot very quickly, and that's what it's going to take. But I just hope they're all successful.
Yep. And December 11th was also the 50th anniversary of the return of Apollo 17.
Yeah.
So it was a great day.
Yeah, it really was.
It was a great day.
Yeah. To touch on, Ryan, your point about risk and, you know, does it all need to be successful on these CLIPS missions and such, I think this paralleling with the Artemis program is perfect in that, you know, these CLIPS missions are uncrewed, they're spread out, they're technology demonstrations. And I think we should expect and embrace failure in a lot of these different robotic systems missions and really see this as an introduction into industry and spreading out this, this space resourcing that we can do. When we get into, you know, human and crewed missions, that's where, you know, safety is going to be the utmost priority. As of right now, we're focused on breadth and learning as much as we can. Failure is okay. Let's kind of set the stage and get people a little bit more comfortable. Break the ice, break the space, sort of. So I think it's okay to fail.
Yeah.
Not everything needs to be a success.
It's the
Especially
spirit
for this round.
It's the spirit of you know, iteration that fuels so much of commercial space. Forrest, any thoughts?
Yeah.
No, I just want to reiterate the new mindset of a lot of these missions is, you know, it is a much higher risk mindset to do these low cost exploration missions, and when you work sometimes with people in old space or, you know, kind of legacy space, and there is a lot of, you know, even though it's a much smaller mission, sometimes there's a lot of additional like requirements that are wanted to push onto these more nimble projects that would, if fully implemented, would completely bog down the iteration speed and, how many missions you could do for the same amount of money. So I think that, taking risk is scary, but that's how we're going to, iterate quickly.
I think that it's obvious that there's a lot of great technology that will be flying on the various ships, if you will. I want to widen the aperture a bit to the role of NASA in all of this, and I know we've touched a little bit already on what's changed, but last night we spoke about this a little bit, and kind of buying services or a little bit down the road, like buying like a landing pad, as opposed to dictating every step. Can you comment on that? Each of you comment on that, and just like the role of NASA as a partner and driver or riding shotgun. I don't know. What are we thinking here?
I think NASA is still, they're kind of the leader in global space. So a big role of NASA is to kind of, be the voice that people look to for how we want to move forward. And in commercializing space, they set the tone. They sign things like the Artemis Accords. They lead for opening up the surface to, resource collection. And so NASA's role, obviously they have lots of funds, and we can talk about, how much they dictate within that, but how they bring the international community together under kind of a unified front of how we want to explore the moon is, I think, the most important contribution for NASA right now.
Yeah, I think Blair said it really nice yesterday in terms of NASA being a customer and not a fully integrated and vertically integrated organization that handles everything, right? The more we can utilize NASA as a customer and look to them as a consultant, a customer and a consultant at the same time, to both get the influential knowledge and the heritage that they have for these different missions and system directorates, but also, of course, it boils down to funding and capital and getting that investment, laying out the infrastructure for commercial to be able to be involved. This is how it works. This is how the aviation industry came about. This is how the space industry is going to come about. So, yeah, just the more we can lean on NASA and government entities to kind of pave the road, but less so have the entirety of the control. And I think the way that it's taken so long for them in the past is every mission has to be a success. But with this shotgun approach, if you will, of what we're doing now and getting everyone involved, I think we can afford more failures and move faster with that funding.
Yeah, and by adding on to both Forrest and Will here is, by NASA making multiple awards under CLIPS, to multiple providers, it's going to be an opportunity for economies of scale and to lower the cost of payload services to the moon. Right now, when you look at, on average, right, you look at what people have bid and what they've won and the payloads that they're carrying, it's $1 million a kilogram to the surface. Is that sustainable in the long run? Is that what the commercial market is going to be looking for? I don't know. Maybe you guys can help answer that question. But I'm guessing we want to drive it down, right? We want to drive it down. That make that cheaper to get there, and that's how the economy is going to grow.
Yeah, I think the biggest challenge NASA faces is, can it change? Organizational change is hard, whether you're a private company, a government agency, because it's a culture. The stories you tell reinforce that culture. How do you go about changing something that has been successful in the past to meet something for the future? And what we're seeing right now is that there are pockets of resistance, there are pockets of innovation at NASA, and the two groups are starting to really run into each other. Fortunately, I think NASA is smart in having a NASA-led component, which is Artemis, and the innovation side, which is the commercial lunar payload service. So right now, there's this duality going on at NASA, but it does affect a culture change, and we're all just wondering how it's going.
Right. What technologies do each of you, and I think that there will be a good diversity of viewpoints and answers here. What technologies do you see as instrumental in fully utilizing the opportunities in cislunar and on the lunar surface?
I'll go last on this.
Sure, I mean, I can take it. There's a lot of them, right? I think the hot topic, a couple of them I can think of. So in situ resource utilization is huge, right? That's going to allow us to really go beyond, even beyond cislunar, and set the stage for going beyond cislunar. To be able to, we talked a lot about, the cost of mass, right, and sending things into orbit. The cost also of bringing these items back as well. But if you could utilize the resources that are already there, I mean, this is how you progress. This is how you can exponentiate your returns, right? So in situ resource utilization, in space manufacturing, all of these things are really interesting and are going to really enable us as different technologies. I think one that we're spinning into once more is human safety and human flight. So I think what's ultimately going to enable us is understanding how do we safely occupy, the moon and safely perform research on different planetary bodies. How do we do that so that we can also exponentiate our return on investment of all of this work, right? So I think that is a huge technology in itself, is safe, reliable human spaceflight for research.
Yeah, so one of the things that Lunar Outpost is very focused on is enabling in situ resource utilization, so we can help build these lunar societies. But when you draw a line back from what it takes to get there, you start seeing all the other parts of infrastructure, technology that needs to be in place. I think a big one is reliable power. We need to get lots of energy to the surface of the moon to do a lot of these processes like molten oxide electrolysis or different sorts of beneficiation processes to separate materials within the regolith. And then the other thing that improves access, of course, is reliable communications. So our rover's going to the moon to test a 4G LTE network for Nokia. That's rover to lander comms. But if we want to travel outside of the range of the lander, we need to have a reliable, satellite comms or some sort of surface infrastructure so that we can continue to drive and operate anywhere. So those are two technologies that I think should come next for enabling the activities on the moon.
And what's the state of play right now? If you had a rover on the moon and you were trying to relay data back to Earth.
Yeah, so the current state of play is our lander is landing really close to an area where there may be water ice. So it's not necessarily in a very sunny location. As soon as the sun goes down, the lander is going to lose power to its solar panels, and then its life is going to be limited. And that's our link back to Earth. So our entire mission is limited to less than 14 days because of that link, even if we drove our rover to a peak of eternal light. So getting some more of those communication satellites in the air is going to be very enabling for longer duration exploration, which effectively lowers the cost of accessing the lunar surface because your mission life to cost of getting the mission to the surface, that ratio increases substantially.
Kevin, any thoughts on key technologies?
Yeah, so I'm from Draper, so you're probably going to guess what I'm going to say. Precision navigation and safe landing. Looking back at Apollo, Apollo had the ability to land autonomously, right? There was that capability. If it were to do that, there was a prediction that it would not land safely 7% of the time because it didn't have any active hazard avoidance capability. As we look forward in the subsequent missions, Surveyor landed safely, didn't have that. Chang'e 4, you don't have any public data on it, but if you watch the YouTube video, it did a divert maneuver. So it had some kind of active sensing on it to detect hazards below. We're going to need that on all the future missions, unless we're willing to accept the risk of landing in an unsafe terrain area. So that's on the lander side, but the navigation side is going to be equally important for all the surface assets, whether it's rovers, whether it's astronauts, whether it's the lunar terrain vehicle. Just looking back at Apollo 14 and how close they got to Cone Crater on that EVA, but didn't know exactly where they were. Now we can know where we are. We can give them guidance to where they need to go. So there's a lot of advances in the navigation technology that we can bring forward for future exploration.
So we have danced around this, but I want to dive right into it explicitly. I've seen a lot of interesting research and arguments and conversations on the topic of the role of automation and all of this alongside or in opposition to crewed exploration and whatnot. Where do all of you land on this? I think that there is a lot of nuance to this. It's obviously not either or, but we did talk about this a little bit last night. So it would behoove us to share everyone's thoughts with the audience, just on the optimal balance between the two, because I think we all would probably agree that one. We're not going to, one's not going to exist without the other. But what are your thoughts on how they complement each other? Obviously, I'll take the easy one right now. The ships are the automated ships are going. But what are all of your thoughts here?
Well, I think it's necessary to have robotic missions first, because there's a lot of things that need to be understood on the moon and beneath the surface. And in order to go find those things out, you don't necessarily have to send a person with a shovel and a pick. You can send a robot. But then ultimately, that will lead to an opportunity for a human to go there and have the experience and make bigger decisions, because the groundwork's been done. And it's been done with robotics that are tightly controlled or self-led. But I think it is a very symbiotic relationship.
Yeah. Will, your company has robotics in its name, so I'll go to you next.
Sure. Yeah, this is a really good question, and I think to build on, Kevin, your point about safe guidance systems, and I think what Virgil in the last panel was talking to as well, automated systems are great. We need them. We need them. Like robotics and robotic equipment is a requirement for what we're trying to do here. But I think it serves a specific purpose in that, setting the path, doing automated logistical tasks, safety redundancies, getting to where you need to go, getting to where you can go safely, knowing where you're at, doing all of these, automated tasks to understand where you're going and how to do it is very important. But the next step of that, in actually increasing the technology and understanding, is sending crew missions. So I think where humans play the biggest role is a little bit what Blair was saying, is bigger, higher level decisions. We need humans on the moon to play around with the moon dirt and run in situ experiments while they're there. So we're not pulling back resources back and forth from the lunar surface and Earth, and it's the reason why we're still using like Apollo data today. It's very important to get humans there, but I think in order to get there, you need some level of automation. But I don't think the answer is let's build a fleet of robots and send them all over, and they're just going to do all the work and that's it. And we sit back and just make high-level decisions all day. I think we're only doing that because that's what we have to do right now. But next, it will be crew, truly human in the loop.
Yeah, I'd like to say that it's actually for the moon. It's turned out to be policy-wise almost humans first.
Yeah.
And because of humans is why all of these additional programs using robots to explore the moon have happened. So economies follow people. People are the economy, right? People making decisions, people wanting things, people deciding to spend money in different resources. And so we need the people in order to have the robots. And maybe the reason why the robots exist is because, we made a decision 10 years ago to go back to the moon, And now we're sending clips, but all of that is to build up for human exploration. So that's to say, I guess, both, but really without the human element, there is no reason to explore.
I think in automation, like the like canonical like phrase is that like robots will take a lot of the dull, dirty, and dangerous tasks. So and that seems to be the spirit of the answers here. With that in mind, what should the priorities be for future Artemis crews? Like, obviously, you know, like to use the ISS as kind of an instructive example or goalpost. Like the astronauts' time is like the most like precious resource up there. So you know, fast forward to boots back on the moon and crews there. Like what are the priorities?
Maybe I'll start if you don't mind, Blair.
Yeah, no, go ahead.
Yeah, so it's a good question, and you know, this question of, you know, human versus robot division of labor goes back 50, 60 years. It's and you know, some of the research out there now is looking to say, okay, well, the humans need something to do. If they're going on a 6-month trip to Mars, they're just not going to be along for the ride. They want something useful, meaningful to do along the way. I mean, if it's the trajectory ends up being a Venus flyby, well, they can do, you know, imagery of Venus for scientific purposes, right? They have a lab on board that they could do that, right? But you know, it ends up coming down to some of what is the, you know, the return on investment, and I think we've seen. Well, you know, the Mars rovers have been absolutely phenomenal. I'm not going to discount that, but you know, someone, I think might have been Steve Squires, one of the PIs, saying, well, if I was there, I could have done what the robots did in 15 minutes, which took them an entire year. So, but it costs a lot more to get a human to Mars as opposed to a rover.
Well, and I think Artemis is going to help us understand what does it really take for the human body to sustain habitation on the moon, habitation on Mars, and other places. We could do it on station. We kind of know what some of the effects are: bone density loss, cardiovascular changes. But in a 1/6 gravity, what does that look like? And so I think the crews of Artemis, which won't be exclusively the only humans on the moon, they'll be private, there'll be other agencies. But I think for the Artemis group, it's really, okay, we're going to have a permanent presence here. Tell us what it feels like. How are you feeling? How are you feeling today? You know, did you do your laps? How's the food taste? You know, that kind of initial understanding, but we are going there to stay, and that's the cool part. Mm-hmm. Now we need to figure out, okay, what happened when you stay there?
Will and Forrest, we touched on this, but the title of this panel is Beyond LEO, but we can learn from low Earth orbit, and you know the proverbial handoff from NASA as they push forward into deep space exploration. What do you think as we look ahead to cislunar and like the decade of the moon? What are positive things that we can take away from LEO and how that has been developed and commercialized, and then maybe some cautionary tales, I suppose.
I think the most important thing is to make the moon relevant and matter to the general public. So whatever we go to do on the moon, it's got to impact the lives of individuals here on Earth. So when we talk about the success of LEO, it's whether it's constellations of satellites, getting information about the environment or the weather, that impacts everyone's everyday life. Whether it's a communication satellite that allows you to make a phone call in the wilderness that helps everyone in their everyday life. So the killer apps for the moon are going to be things that help every single person in this room. And so finding those, I think, is, you know, part of our company's goal in our exploration of the surface.
Yeah, I think that's a really good point. I think there's a huge gap between LEO and beyond LEO, right? Because as you just said, Kevin, sorry, not Kevin, Forrest. There's lots of, you know, direct return on investment for LEO, and for beyond LEO and a lot of the moon operations that we're trying to do, it's much further beyond what we're looking. So the initial return that we're seeing isn't as easy to get, the entire population to have a benefit right off the bat. I think it's going to take a lot of buy-in, a lot of the science community. There's going to be a lot of things to learn that will, further our understanding of a lot of things. And I think that's what's going to be the real value until we, actually get there.
I think that harkens back to the earlier discussion about long-term horizons. And on the topic of long-term horizons, I want to save the last little segment we have for what comes after and in situ resource utilization. But before I do that, I want to open it up to audience questions if anyone has any quickly.
Yeah, I have a quick question regarding going back to CLIPS. So you mentioned that kind of duality at NASA with So you mentioned kind of the duality at NASA between accepting risk or kind of the faster, better, cheaper, we're scared of this, we're not going to do it. But we see a lot of low-cost programs at NASA over time just increasing. We saw that with CLIPS, with the interplanetary CubeSats, and we see that now with Viper being on CLIPS. So I was wondering how you see the future of CLIPS with that. And the other part of the question, do you see any expandability of CLIPS to beyond the moon? Because we don't see as much market there, but I was just curious if there's any potential there.
Yeah, it's a great question. I think CLIPS is sort of that on-ramp for NASA to engage commercial entities without taking them over. And I think there's been a lot of positive feedback, so I would expect to see more programs like that coming from NASA for other places. But the Commercial Lunar Payload Service was really that first jaunt to being just a customer in the private sector. And I hope they continue to do it. I mean, how many task orders have they awarded?
5 or 6 now.
Yeah, and they have 8 more on the board. So
the one I think your question was at cost growth, right? The CLIPS task orders are firm fixed price services contracts. So there's not a lot of margin for you to go over what you bid, because now you have to own it, right? So it makes it very challenging from a project management perspective, but you have to go in knowing what risk you're going to accept in terms of your development activities.
Yeah, and are we surprised that the cost is increasing? I mean, this is the first thing, right? So we have to get through a few of these to understand and have a better idea. It goes back to the investors, knowing how to approach this ecosystem and this realm, right? So it's going to be a learning experience. It's going to take a lot. There's going to be some failures. And yeah, a lot of the liability falls on the companies that are sticking their neck out and saying, hey, we could do this for this price. And who knows if they can or can't, but they have to own it.
Last question, since we're pushing under a minute here. On the topic of what comes after and in situ resource utilization, what are your thoughts there? Like, is that I don't want to be super cliche and use like the Silicon Valley term, but is that like the killer app of developing cislunar space and the surface?
Well, yeah, I mean, effectively the moon is a whole new continent to us. And just as people arrived here at Plymouth Rock, and then it was like a generation later, they found great oaks and sent them back to Europe, right? Which improved shipbuilding capability. We don't really know what the lunar towns are going to find, but they're going to find something, and it's going to participate in helping us here on Earth. So I think all of this stuff is to be ready for 2026, 2027, when we actually start building the town and having people arrive.
So I'm 13th generation from the Mayflower. We came here to explore. We say we've been spending a lot of time on Beyond LEO and cislunar, but we all know our ultimate goal is Mars.
All right. Well, just want to, my last name's Duffy, so I'd be remiss to not say happy St. Patrick's Day to you all. I also want to shout out to the Sloan students for putting on a great event. And thank you all for attending.